Hi, so today we are going to focus on the trigonometric function. So it's basically the integration of the trigonometric function. So they can ask you to integrate sine, cos, and so on. But the most complex function that you are going to focus on are those that have the exponent. So you have, for instance, a function which is written in terms of a trigonometric function and an exponent. Okay, let's say for instance y is equal to sine to the power of n ax. So you have another function like y is equal to cos to the power of n ax. So you can have like cot to the power of n x and so on. Or you can also have a product of the two trigonometric function. So let's say you have something like sine to the power of m ax multiplied by cos to the power of n bx. So how can you integrate this type of functions? Okay, let's say for instance we have, so let's say we have to integrate one of these functions. So the first thing to do before you understand this chapter is to be familiar with some of the trigonometric identities. So you need to know these few identities. So the first identity is the first one is, so sine to the power of 2 of ax is equal to half minus half cos 2ax. And the second one is cos square ax is equal to half plus half cos 2ax. So the difference between these two identities is the sign. So here for cos we have a positive, but negative for sine. So the third one is sine square ax plus cos square ax is equal to 1. This is also known as Pythagoras identities. And the fourth one is tan square ax is equal to sec square ax minus 1. And the last one is cot square ax is equal to cos ax minus 1. So we are going to apply these identities in order to integrate this type of function here. So now let's take some examples. So let's say we want to integrate the trigonometric function having an exponent n. So if n is even, so for n is equal to 2, 4, 6 and so on, so we're going to apply a certain rule. Okay, for instance, if we have to integrate sine to the power of 4ax, so I need to write my exponent in such a way that I can apply the identity laws that I've written in the previous slide. So what I'm gonna do here is I can write sine to the power of 4 as sine to the power of 2 ax and everything to the power of 2, and then we have dx. So now there is an identity laws for sine square ax, because I know that from the previous slide I have this. So sine square to the power of ax, sine square ax is given by this expression here. So half minus half goes to ax. So all I need to do is I just need to replace this part here. So I have half minus half goes to ax, and then I still need to repeat that square. So I have square there and then dx. So the next thing to do is to expand. So I have to expand the expression that is within the bracket. So I'm gonna have, so remember that if you have a minus b square, so that gives a square minus 2ab plus b square. So this is an identity law of factor to expand an identity relation that is applied in factorization. We can also use the binomial theorem. So if I expand this, I'm gonna have 1 over 4 minus, so I have half multiplied by half, I get 1 over 4. 1 over 4 multiplied by that 2 gives 1 over 2 cos 2ax, and then plus, so I have b square. So b square represents the cos. So I'm gonna have cos, b square represents half times cos 2ax. So I need to find the root of that. So I'm gonna have 1 over 4 cos square 2ax, and then I have dx. So now we can see that I can still apply the identity law that I've written in the previous slides. So I'm gonna apply it to cos, because I know that, so the relation for cos is cos 2ax is equal to half plus half cos 2ax. So that is cos square 2ax. So this is what I have here. So I just need to replace, to substitute the cos by this expression here. So I have 1 over 4 multiplied by, so this is the expression of cos square 2ax, so that gives 1 over 2 plus 1 over 2 cos 2 ax, and then I close the bracket. So now I'm gonna try to simplify a bit the expression that's within the bracket. So I'll leave 1 over 4 there minus half cos 2ax. So I have half 1 over 4 multiplied by 1 over 2, so that gives 1 over 8. So if I multiply it again there, I'm gonna have plus 1 over 8, and then I have cos 2ax dx. So I noticed that I have some like term. So here we actually need to have 4ax, because remember that I'm still applying this another identity laws. So if I say cos square ax is equal to half plus half cos 2ax squared. So now what if I have cos square of 2x? So it's gonna look like this one, but except that instead of having 4, instead of multiplying ax by 2, we're gonna have 4. So we're gonna have half plus half cos square of 4ax. So this is what we have here. So we actually need to change that. So these two should be turned into 4. So now, so these two are not like terms because we have 2ax there, but here we have 4ax. But I can see they are like term, like we have 1 over 4 plus 1 over 8. So we're going to have integral of the sum of these two, that so that gives 3 over 8, and then minus cos 2ax plus 1 over 2 cos 4ax dx. Okay, so far I haven't yet integrate. I was still applying the identities to transform my initial expression. So now I can say that the expression that the term that within the bracket are very easy to integrate. I can just rely on the fundamental formulas that are given in the table. So we are going to have, so we actually need to integrate all the terms that are inside the bracket. So starting with 3 over 8. So 3 over 8 is a constant. So if we integrate the constant, we get 3 over 8 x. So what is the integration of cos? The integration of cos gives, because when I derive sine, I get cos. So when I therefore when I integrate cos, I'm gonna get sine. So I have sine 2ax. So when you integrate, you always divide the expression that you get by the coefficient of x. So in this case, the coefficient of x is 2a. And then we have half multiplied by, so when you integrate cos, we get sine. So we have sine 4x, and then we divide the coefficient of x in this case, which is 4a. So we need to divide this by 4a. And then we add a constant. So the final answer is just a simplified form, which is 3 over 8x minus sine 2ax over 2a plus sine 4ax. So I need to multiply these two terms. So we have the multiplication of two fractions. So we multiply the numerators to each other as well as the denominators. So we have 8a plus k. So that's the final answer. So remember that when the exponent is even, you're gonna have to write the trigonometric relation in terms of the exponent 2. So let's say, for instance, you have sine to the power of 8. Then you need to write it in terms of sine to the power of 2. So we're gonna have sine to the power of 2 multiplied by everything to the power of 4. So now we're gonna apply the expansion of this. So you first replace your sine to square by half minus cos 2ax over 2, and then everything we're gonna have to the power of 4. So now you have to apply the expansion of this bracket. You need to expand it, and then later on I use the integration. So now let's look at an exact example of integration of trigonometric function in which the exponent is not even. So in this case the exponent is odd. Okay, let's say, for instance, we have to integrate this function here. So you have sine to the power of 3 2x dx. So in this case n is odd. So if n is odd, so you just need to make sure that you need to write your function in such a way to visualize the exponent 2. So in other words, you need to write the function in terms of sine to the power of 2x. So how to do that? Sine to the power of 3 2x dx. So the first step is to write this function in such a way that we can see the exponent 2. So we can write it as sine to the power of 2x multiplied by sine 2x dx. Because if you multiply these two expression, you get sine to the power of 3 2x. So now you now focus on the expression that have an exponent of 2, this one here. So you find the trigonometric identity of this function here. So you know that sine square plus cos square is equal to 1. So when the exponent is odd, so we always think of using this identities. So now I can write this sine square in terms of cos. So I can say sine square of 2x is equal to 1 minus cos square of 2x. So this is what I'm gonna have here. So I just replace all this by 1 minus cos square 2x. And then I have sine 2x dx. So now the next step is to do the substitution. So I'm going to say let u is equal to cos 2x. So if there is sine here, we use cos, but if there is cos there, then we're gonna use sine. But in this case there is sine, so we're gonna say u is equal to cos. So always do use the opposite. So now the next thing is to differentiate both sides. So you can say du is equal to, if I differentiate this, I get negative 2 sine 2x dx. So now I can make dx subject of formula from this expression. So I'm gonna have dx which is equal to du over negative 2 sine of 2x. So now the next step is to replace. So I need to write, so I'm focusing on this expression here. So I need to write everything in terms of u. So it means I'm gonna have integral of 1 minus, because we say u is equal to cos 2x, then cos square 2x will be u squared. So there is not an expression which is so there is no an expression which is that shows sine 2x in terms of u. So I will keep it as it is so long, but I have dx here which is written in terms of u. So dx is equal to du over sine 2x. So now at the end you are going to realize that these two sine can cancel, then you will only remain with an expression which is written in terms of u. So we have du and then we have negative 2. But that can also be written as negative half times integral of 1 minus u square du. So the next step is to integrate. So if we integrate that, we get u minus u to the power of 3 over 3 plus c. So now at the end, I'm gonna have to replace u by its expression, so it's trigonometric expression. So I'm gonna have negative half, so u is cos 2x. What's u in terms of cos 2x? U cube will be cos 2x to the power of 3, then divided by 3 plus the constant. So this is the final answer. So let's look at another example here. So in this case we have the combination of cos and sine. So let's say for instance, but for both cases the exponent is even. So we have for instance sine integral of sine square x multiplied by cos square x dx. So that is the same as integral of sine x multiplied by cos x and everything to the power of 2, then dx. So I'm gonna use a trigonometric relation of the product of sine and cos. So you know that 2 cos x multiplied by sine x gives sine 2x. So this is the relation you also have to know. It's very important. So I'll just replace, if 2 cos x and sine x is equal to 2x, then cos x multiplied by sine x will just be equal to 2, will just be equal to 2 sine 2x divided by 2. So just bring this 2 to the other side and it's gonna divide the right hand side expression. So I have sine 2x over 2 and then square dx. So that gives the integral of sine square 2x and 2 to the power of 2 dx. 2 to the power of 2 gives 4. So we have 1 over 4 which can that can go outside the integral, and then we have to integrate sine square of 2x dx. So again I can still apply the identity law for sine square of 2x. Sine square of 2x, so I have to choose the laws. So I have to choose the law, the expression that doesn't present the exponent. So if I have sine square of 2x, it gives half minus cos 4x. So as you can see, this cos doesn't have an exponent, so that means I can easily integrate. So replace this by half minus half cos 4x dx. And then next I'm gonna apply the integration. So I got half, so x over 2 minus, so the integration of cos gives sine, so I actually have sine cos x, so I also have half in front, and then when I integrate I have to divide what I have here by the coefficient of x, which is 4 in this case, so I need to put 4 on the denominator. So next I have x over 2, half multiplied by x over 2 minus sine 4x over 8 plus k. So that's the final answer. So the general form of the integration of function that include cos and sine are given as follows. So you actually need to know how to integrate this type of function. So we have sine to the power of m, so we have ax, and then cos to the power of n, so you also have ax there, and then dx. So sine has its exponent s, and for cos we have n. So m and n can either be even or odd, depend on the problem that is given. Or the examples that we just completed the previous slide. So it's part of this formula here, because we have the combination of sine and cos. But in the example that we did, the value of m is equal to the value of n. So what if m and n are not the same? For instance, they can ask you to integrate this function here. So you have sine 3x and cos 5x dx. So all you need to do is you just need to write one function in terms of the product of separate function. Okay, like here we have sine and cos. So you can either choose sine or cos, doesn't matter. Okay, in this case, let's separate sine to the power of 3 in terms of two separate functions. So that is, you can maybe write it in terms of sine to the power of 2 and sine. So you have sine to the power of 3, which is equal to sine to the power of 2x multiplied by sine, and then multiply by cos of x to the power of 5. Then we have dx. So now the next step is to write So you can see that there is something to the power of 2. There is an expression that has an exponent which is 2. Then I can apply, so I can apply the identity law for that, because I know that sine square of x gives 1 minus cos square of x. So I can replace sine square of x by 1 minus cos square of x. So that gives 1 minus cos square of x multiplied by sine x multiplied by cos 5 of x, and then I have dx. So now I'm gonna have to multiply these two, because I've realized that they are like terms. So if I multiply them, I'm gonna get cos to the power of 5x minus cos to the power of 7x, and everything multiplied by sine x, and then I have dx. So now the next step is to use the substitution. So if we say let u is equal to sine, so if there is sine here, then I'm gonna have to use cos. So when I start with my substitution, I'm gonna use the opposite. So for sine we use cos. If there is cos, then I'm gonna use, then there should be sine here. So we say let u is equal to cos x. So therefore, if we differentiate both sides, we get negative sine x dx. So now the next thing is to find the value of dx. So to find the expression of dx, so dx is equal to du divided by, or negative du divided by sine of x. So now I can write this expression here in such a way it's only visualized u. So I have the integral of, so if u is equal to cos x, then cos to the power 5 is equal to u to the power 5. Cos to the power 7 is u to the power 7. So there was no expression for sine x in terms of u. I'm gonna keep it as it is for now, and then I have dx, which is given by negative du over sine x. So the next step is to simplify. So I can simplify these two, and then at the end I'll remain with, so I have a negative sign there which can goes in front of the integration symbol, and then I have u to the power 5 minus u to the power 7, and then I have du. Then I can apply the integration rule to this polynomial. So that gives u to the power 5 over 5 minus u to the power so here I need to have 6 over 6 minus u to the power of 8 over 8 plus k. So now the next things to do is to replace the value of u, to replace u by its trigonometric expression. So we have negative, so u is equal to cos x. So we have cos x to the power of 6 divided by 6 minus cos to the power of 8, cos of x to the power of 8 divided by 8 plus c. So that is the final answer. So that's it. So in this case we have a multiplication of two different trigonometric functions. So in this case we have sin x and cos x. So the next type of function will involve the tan and the cotan. So I'm going to explain how to integrate a function tan to the power of n ax dx, and then we have another function cot ax to the power of n dx. So that n represents the exponent. So the exponent can be odd or even, it depends. So for these two functions you need to know, so you need to remember this two identity. So for tan, so tan square ax is equal to sec square ax minus 1, and for cotan square ax, so we have cosec square ax minus 1. So these identities will be used when so for n which is even, so if the exponent is even, then we need to think about these two identities. So let's say for instance we have the integral of tan square of x dx. So in this case, okay, let's use 10 to the power 4 dx. So the first step is to write the function in such a way that it presents 2 as exponent. So what I'm gonna do here is I'll just say 10 to the power of 2 and everything to the power of 2 dx. So that is the same as 10x to the power of 4. I can also write it as 10x multiplied by 10x and then have dx. So now we're gonna write 110 in terms of sec. So that is the same as 10x. Okay, I'm gonna take the second 10 and then write it in terms of sec. So I'm gonna have sec square of x minus 1 and then I have dx. So next I'm gonna do the substitution. If I say let u is equal to 10 of x, then the derivative of u will be equal to sec square x dx, because when you derive 10 you get sec square. So I can say that dx is equal to du over sec square of x. So now the next thing is to replace so something there, we have 2 there, 2 there, 2 there, and so this is actually the results of 10 to the power of 2x. So I'm going to realize that this expression can also be written as, so I can multiply, I can expand these two brackets. So I'm gonna have 10 square x multiplied by sec square x minus 10 square x. And then from here I can say let u is equal to 10x. So I find the derivative of u. So I get du, which is equal to sec square x dx. So we are actually applying the integration of this. So the next 10 can be written in terms of cos, in terms of sec. So we actually have 10 square x sec square x minus, so 10 square is equal to sec square x minus 1. So you are actually integrating this function, so which is similar to 10 to the power of 4x. So if I do it on this slide, I mean on this origin, so I have the integration of, so I have the first term, which is 10 square x sec square x dx plus, so the second term is sec square x dx, and then the last term will be plus the integration of 1 dx. So the reason why I have 1 here is because we have two negative sign when they multiply. So we get a positive. So I know that, so now I need to find the integration of 10 square x and sec square x. So I have the product of 10 and sec square. So that's where I'm gonna say, so we say u is equal to 10x. And then what is the derivative of u? The derivative of u gives sec square x dx. So dx is equal to du over sec square of x. So I first need to integrate this function here. So what am I gonna get? Because I say that u is equal to 10x, so I can replace 10x there. So I'm gonna have 10 u to the power of 2. And then here I have sec square x. So this is dx. So dx, the value of dx is du over sec square x. So the sec can cancel. So I'm gonna have the integration of u du. So that gives u to the power of 3 over 3. So that I will now replace the value of I will now replace the expression of u, which is 10x. So I finally have the first integration gives 10x to the power of 3 over 3. So that was the first integration. So we have I1, and then we need to find the second integration that we can call I2. So the second integration is very simple. All we need to do here is we just replace dx by du over sec square x, and then the sec will cancelled. So I2 is equal to the integration of sec square x dx. So dx is equal to du over sec square x, and then from there we can the sec can cancel. So we're going to have the integration of 1 du. So I2 is just equal to u. In other words, I2 is 10x. So now we need to integrate the last term, which is 1. So the integration of 1 gives x. So now the final expression will be the combination of I1, I2 and I3. So in other words, we have this. So the integration of then 4 x dx gives, so if first have I1 which is 10 to the power of 3 x over 3, and then I2 is equal to 10x, and then I3 represents the last term, which is the integration of 1 dx. So that gives I3. So we get x and then plus k. So that's the final answer. So remember that we have a negative there. So that needs to be a negative, therefore that also needs to be a negative.